This is Dr. Holt. This video is on projectile motion where you have an initial velocity that is in the horizontal direction only. This example, I have a box that's going to slide with a speed of 3 meters a second across a table that is 1 meter above the floor. Here's the box that's coming across the top of this table at 3 meters a second. The table is going to be 1 meter above the floor, as stated in the text. What we want to do here, we want to find out how far from the table will the box hit the floor. The box is going to come off like a parabolic, follow a parabolic path, going to hit down here. So we want to find out what this distance here will be. Call that delta x. Here to here. Here to here. We want to find out what the velocity is going to be when it hits the ground. And we want to find out what this angle here is going to be, theta here. Alright, we can do this using our kinematic equations. We know that delta x here is going to equal to vi times t plus 1/2 times a times t squared. Now the thing about these projectile motion problems, you have nothing that's causing the object to accelerate horizontally. So we can just take this part out. The acceleration here goes to 0. So we can erase that part of the equation, and we just end up with horizontal displacement is going to equal to the initial velocity times time. Now we think about our vertical equations, kinematic equations. Again, our initial velocity when this object comes off the table, initial velocity in the y direction 0. So we will just really have this equation here. So all I'm saying on this one is the displacement in the y direction is equal to 1/2 times at squared. Same thing we're trying to do here, but the acceleration here exists as negative 9.8 and you have no initial velocity. Alright, so now we want to find out what this distance here is going to be. Well, what's driving the time in this example here when this thing comes off horizontally is going to be this equation here. I'm limited by how much height I have. So my change in y would be -1 here because I'm falling 1 meter down. So -1 is equal to, multiply that gives me -4.9 times t squared. We divide by 4.9, so 1 divided by 4.9. Again, my negatives are going to cancel out. We take the square root of that. That's going to give me my t value. So run that real quick through the calculator. Take 1 divided by 4.9. Second square root, second answer. That gives us a time 0.452 seconds. So that's the time it's going to take for this object to fall from here to here. That's how long it takes. Same thing, if I even dropped a ball right here, that's how many seconds it would take to come down and hit the floor. Alright, so now that we have our time, we can put it back into this equation here. And we know our delta x here would equal to our initial velocity, which is going to be 3 times my time of 0.452 times 3, and that's going to give me a displacement of approximately about 1.36. Okay, so we can erase this, and we know this right here is just going to be 1.36. and 1.36 meters. Alright, now let's find out what the velocity is going to be. The thing to note on this, when this object is falling along the parabolic shape, this 3 meters per second horizontal is never going to change. It's going to be 3 meters a second horizontal everywhere through this parabola. Even when it hits the ground, it's going to be going 3 meters a second horizontal. All we need to do is find out what the vertical velocity is going to be when it hits the ground. So we will use our kinematic equations. And the easiest thing to do, I mean, there's two ways you could do this, and I'll show you both of them. You can use this equation here. Our VF squared is equal to VI squared minus 2 times 9.8 times delta y. Now this equation's fine. You could use it right off the bat to find out what the velocity is going to be at impact. You can use that, or you can go back and use this equation. VF is equal to VI plus AT. Now I'm going to use this one. Again, it makes no difference because I know my time. So my final velocity in the y direction only is going to equal to, now the initial was 0 minus 9.8 times my time of 0.452, because that's how many seconds it was in the air. If I take that value there, I'm going to give out a velocity of negative 4.427 meters per second. Alright, so I'm going to blow this area up here and show you what's taking place at impact. At impact, I'll make this dot be the impact. I'm going to have a velocity at impact coming in this direction here. Again, that value is going to be in what it was originally, 3 meters a second. This value here is going to be my vertical component, and now I'm going to make it 4.427 meters per second. The negative only gives me the direction going down, and then my hypotenuse right here is going to be the magnitude, and to find the magnitude I just use Pythagorean theorem. My V final at impact is going to equal to 3 squared plus 4.427 squared. I take the square root of that, so we'll do that real quick. That gives me a velocity at impact of 5.348 meters per second. So that's going to be my velocity at impact. Oops, I don't want to do that in yellow, I want to do it red. Then we have velocity at impact. Again, now I want to find the angle. Typically what I do with these is finding the angle coming off the horizontal. Meaning if we redrew that, let me just clone this. So really what I'm looking for is this angle here. Now if this is theta here, this angle here will be theta here because those are vertical angles. So the easiest thing to do is to do the inverse tan. Again, I do the tangent. It's going to equal to 4.427, which is the opposite, divided by 3. That's going to be the tangent of theta. So theta is going to equal to the inverse tan, 4.427 divided by 3. We run that value there, 4.427 divided by 3. Second tan, second answer. I'll get an angle of 55.88. Within, again, that's within rounding error. And that's going to be the angle at impact. Now, the thing you could have done, and it makes no difference, nothing says you have to do the tangent. Since you know what the what this one is, you could have done an inverse sine or inverse cosine. Either one would have worked fine. Alright, again, there's the first problem I want to solve. Pretty straightforward. The most important thing to note is to note there's no acceleration ever horizontally with these type of problems unless it's going to be stated. You're not going to see that until you get into a higher level physics class. The other thing to note is that this velocity horizontal is going to be constant throughout. The second thing to note is when you come off here, the initial velocity in the y direction will be 0, and that's going to increase in magnitude as it travels along the parabola. Alright, hope this video helped you. Best of luck with these type of problems.